Okay, so I first taught you how to solve these by making all of the denominators become the same thing and then just ignoring the denominators, okay? Basically now what I'm going to show you is kind of just a little bit shortcut as far as, basically what I'm going to do is I'm going to be able to get rid of fractions. I'm going to go from the problem, I'm going to jump down to this step almost right away, okay? Without having that middle step, basically. Okay? When you have an equation, any equation, if you multiply both sides of the equation by the same number, is that okay? Mm-hmm. Yes. Okay? So, when I do these problems, all right, what I like to do is I like to multiply every term by the least common denominator. Because what that'll do is that'll get rid of all fractions. Okay? So I'm going to multiply every term by the least common denominator. Well, what was our least common denominator? X minus 5, right? Okay? So I'm going to multiply this by x minus 5, just on the top. I'm going to multiply this by x minus 5. And I'm going to multiply this by x minus 5. Okay? I'm going to multiply all the terms by that same number, x minus 5. All right? So, when I do that, all right, when I do that, look what I'll get. This will just give me what? X minus 5, or how about x squared minus 5x? I'll even distribute it. X squared minus 5x. When I multiply this by x minus 5, what could happen to the x minus 5s? They cancel, and I just have minus 8x. And how about over here, what's going to happen? X's cancel, and what are you left with? 3x minus 15. And I'm already to that step. Set it equal to 0, factor it. Okay? So it's just a little bit of a shorter method to get to this stage right here.
You have to go and find your least common denominator.
You still got to know what your least common denominator is. I'm just not going through the process of making all of the denominators become the same thing. I'm just multiplying every term by the least common denominator, because then what that'll do is that'll cancel out every denominator you have. So it's like you're getting rid of the denominator all in one step. Okay? Questions on what I did there?
How come you know how to do both the top and bottom?
Okay. It's okay to do this because really I'm multiplying both sides of the equal sign by the same number. You know, like if I had this, would it be okay for me to multiply both sides of the equal sign by 3? I mean, if I take this times 3 and I take this times 3, is that okay? Yeah. And why is that beneficial? It makes me get rid of fractions, right? So I'm doing the same thing here. I'm multiplying both sides of the equal sign by whatever this number is, this x minus 5. So, and why? Because it gets rid of fractions for me. That makes some sense?
What's the difference between that and what you just did? Like, that just like, it's not showing your work, or the same thing?
It really is, except the previous way, I'm not multiplying everything by the least common denominator. I'm creating or making everything have that least common denominator and then getting rid of it. So it's not different in a sense. But I just didn't want to go straight to the shortcut method. I wanted you to see why it works kind of first. So that's why I kind of showed this way, even though I know you're going to do it the other way. But yeah, it's slightly different because in this method, I'm making every fraction have the same denominator and then just ignoring the denominators, where this method is me just getting rid of denominators by multiplying everything Not by what it needs, but by the entire least common denominator. So it's slightly different, but it does the same thing. Okay. Does that answer your question?
Yeah.
Okay. All right. Anything else? Okay. I'll do one of your homework problems with you here. Number 18.
It's x equals 1 and x equals 6.
Awesome. All right, that's number 18 from your homework, so we'll start with 18. All right. So if we do it the way, that second way that I taught you, just to do one more example that way, we need to first decide what is our least common denominator.
X plus 2, x minus.
X plus 2, x minus 2, yep, okay. X plus 2, x minus 2, that is our least common denominator. So I'm going to multiply every single term by that, okay. I'm going to multiply this one by x plus 2, x minus 2. I'm going to multiply this one by x plus 2, x minus 2. And I'm going to multiply this one by x plus 2, x minus 2. On the first one here, what can cancel?
X minus 2's.
The x minus 2's can cancel. What am I left with? 1 times x plus 2, which is just x plus 2, right? Okay? This one's a little bit tougher. I'm going to take a little bit of a shortcut method here. So I got to take 2 times x plus 2 times x minus 2. Okay? Personally, I take x plus 2 times x minus 2 together first, because actually I know that without even foiling, because these would be the two factors for what? X squared minus
4.
4. Yep, the difference of two squares. So if I take this times this, I get x squared minus 4 times 2. Well, what's 2 times x squared minus 4? 2x squared minus 8. Good. So plus 2x squared minus 8. You guys might have to FOIL that out, but I'm just for speed purposes and going a little faster. On the last one, what's going to cancel?
X plus 2.
X plus 2, so that's nice. And I got 3x times x minus 2, which would be how much?
3 squared
3x squared minus 6x.
Good, yep, 3x squared minus 6x. Here you go, you got another quadratic equation. How do you solve quadratic equations?
Set them equal to 0.
Set them equal to 0 and hope that they're factorable so you don't have to use the quadratic formula. I'll make sure they're factorable.
Yeah.
Okay?
That's fine.
All right. Think a little bit here, not that it really matters, but what side of the equal sign do you think I'm going to move everything to here?
Left.
Right. Because I want a positive 1x squared. If I subtract 3x squared from both sides, that would give me a negative 1x squared. It's not very much to factor with negative 1x squared. Not that you can't change it to positive 1x squared by changing the signs on everything. But me personally, I'm going to just move everything over there. Okay? So I'm going to subtract 2x squared from both sides. I'm skipping a lot of steps here. I'm going to subtract 2x squared from both sides, so that gives me what over here? Just 1x squared, or x squared. I had negative 6x on the right side, but I'd have to subtract x from both sides, so that'll give me how much? Negative 7x.
Then you gotta
And I had
Add
positive
8
2
and
minus 8. I
subtract
had a negative 6 on this side,
set
so I'd have a positive 6 on the other side. Is that factorable?
See,
Yep.
6 more.
Okay. What are the factors?
X equals 1, x equals 6.
X minus 6, x minus 1, so x equals 6, x equals 1. Again, for time purposes, they do both work. Okay? If you plug them in, they do both work in the equation, and those are your two answers. Okay? All right.